Hello everyone. Today we're going to discuss about Versa's SD-WAN QoS and how the SD-WAN QoS works compared to our standard QoS model, which is basically HQoS, which is hierarchical QoS. So as part of today's training, we are going to cover a high level on how the QoS works in SD-WAN. What is application QoS? What are the various options available within SD-WAN to rate limit, police and schedule the traffic? And furthermore, we are also going to discuss about various configuration scenarios on what kind of QoS use cases customer comes up with and how to configure that in the SD-WAN portal. So let's begin. So SD-WAN QoS, right? So how does it work? So we are talking about Versa SD-WAN QoS, which uses Intel DPDK technology to provide software queues. So there's a difference between software-based queues and hardware-based queues. In your traditional Cisco HP routers, what you have is hardware-based queues, which means every interface has its own queue, and those queues have 6 to 8 queues based on the hardware model. Similarly, in SD-WAN, since it's all a software-based service, which is running on an x86 platform, so every SD-WAN device will have software queues. So similar to your hardware queues, we also have software queuing. So that has been based on the technology of Intel DPDK, right? In addition for that, every SD-WAN device has something called as DPI, which is nothing but deep packet inspection. So which identifies the traffic based on the application fingerprinting or URL category. So URL category is again identified based on the SNI and URI segments. So you can Google it up on what all these terminologies are. So SD-WAN, let's say you're trying to browse from your mobile, right? So you're connected to the SD-WAN device via Wi-Fi or a switch. So SD-WAN device understands that using a technology called as app ID detection. So basically it identifies that this is a mobile application which has been browsed, and this is the app ID for that. The app ID is Facebook. So based on that, it identifies the application after the first flow is detected. Similarly, for URL, you go and type yahoo.com in the website, in the web browser, right? So it's going to identify that it's a URL based on the application and URL signatures it has. So that has been sourced from the Versa's research center. Next, how does a packet get classified and scheduled all the way when it enters the LAN VR and exits via the WAN VR? So we're going to see that. So if you look into the diagram, you can see that there is a classification happening for the traffic. So there is a traffic coming in, which is shown as RX, receiving traffic on the LAN VR. So this is the traffic which comes from the customer's LAN segment, right? So it can be a LAN switch or a LAN router or a LAN firewall. So the users are sitting behind the LAN switch or firewall and they are trying to browse some applications. So the flow comes into the SD-WAN device. It will do a deep packet inspection and it is going to identify whether it's a L3 based flow or a L7 based flow, right? So when we say L3 based classification or L7 based classification, it depends on the kind of rule that we have defined. Whether we are going to identify the application either based on application, which is L7 fields, or are we going to identify it based on IP DHCP values? Once that is done, we are also going to say that before the queue exits, the traffic exits the SD-WAN device, whether I should rate limit the traffic. Let's say you don't want browsing, which is basically streaming media, which is YouTube or any other video-based websites, to not cross more than, let's say, 1 MB. So you define a policer rate. So this is the same concept as we have in Cisco routers, which is policing the traffic. We are rate limiting the traffic at the ingress itself. The next stage, whether you want to remark the traffic before it goes to the provider edge router. So people who are familiar with SD-WAN, your MPLS based QoS, you might come across terminologies like packet remarking, right? So basically it's done in two ways. Either the customer marks the traffic based on DHCP values, which is AF49, AF42, AF31, EF, etc. Or we as service providers, we remark the traffic in the CE router based on IP addresses, which can be either based on source-based IP addresses or destination-based IP addresses. And now the provider edge routers, once it receives the QoS marking, we will be doing P2P QoS in our backbone. So do we need to do that? If no, we can skip to the next step. So the packet gets remarked if it's required, otherwise it directly moves on to the fourth step, which is queuing. So in SD-WAN, there are close to 16 queues. So I'll explain that in a bit more detail in the upcoming presentation. The next is scheduling the traffic. So what kind of traffic priority should I give to the traffic, right? So what is a allocated bandwidth per queue, like how we define a QoS 1, QoS 2, QoS 3, QoS 4, QoS 5, QoS 6. These are different kinds of cost models that we have. So how should I prioritize the traffic and put the traffic in which queue is done in the scheduling. So once the scheduling is done, the traffic is assigned to the queue. Queue rate limits the traffic accordingly, according to the bandwidth, that is CIR and the PIR that you assign. And then the traffic is given out to the provider edge router. So we are discussing about SD-WAN forwarding profile. So SD-WAN has 16 forwarding classes, namely network control, expedited forwarding, assured forwarding, and best effort. And within each forwarding class, there are 4 queues each, meaning you have 4 into 4, 16 queues to push your traffic, right? So, and also all these queues are scheduled in a weighted round robin fashion, and which ensures that every packet is serviced from top to bottom. So you can have a question like, what is a strict priority queue over here? So obviously the strict priority queue is NC and EF. After that, all our data queues, which are AF and best effort, are data queues. We can define accordingly. But always the traffic is serviced first, NC, EF, AF, and best effort. So that's how the traffic is classified. As part of SIFI's SD-WAN QoS deployment, this is the architecture that we're going to follow. For expedited forwarding, we're going to put QoS 1, which means any media related traffic, any voice related traffic will always go on QoS 1 queue. And the traffic class it belongs to is 1, and the queue it will belong to would be 0. And within expedited forwarding, if customer expects us to put one more traffic, then it will be under forwarding class 5 with a queue number 1. So what is going to happen is, if a traffic for IP phone is coming, it's going to be serviced via the queue number 0. If there is a traffic coming in for video conferencing, it's going to be serviced via the second queue within expedited forwarding traffic class, right? So that's how the servicing will happen. First, the traffic queues, and so as I told you, the servicing happens top to bottom in the forwarding class, which is from FCNC all the way till FCBE. Now, in the same fashion, the traffic classes are defined. So FCNC is defined with 0, EF with 1, AF with 2, and best effort with 3. Now, within these queues, within FCEF, you have 4 subqueues. And now, let's say so I told you how the traffic is classified, right? So now, the queue mapping, right? So within this queue, how the queues will be serviced, it will be from top to bottom. First, the queue 0 will be serviced. Second, the queue 1 will be serviced, and so forth. And then the remaining queues will be serviced. So that's the order of the traffic, that is the order of the traffic classification. Now, right, so this is more about how the traffic class behaves, right? So let's discuss about schedulers and scheduler maps. So people who are familiar with Juniper, they will be familiar with the terminology scheduler and scheduler maps, and people who are familiar with Cisco will be familiar with the term class map and policy map. All right. So now, scheduler is a place where you define what is a queue priority and what is a queue bandwidth, right? So let's say a customer subscribes for a 10 MB link from us. So he says, give 2 MB for my voice traffic, 3 MB for my media traffic, and remaining can be used by my default browsing traffic. So how do we define that, right? So we define what is a minimum amount of bandwidth that a queue should have. As a customer told, he needs 2 MB for EF, 3 MB for his data traffic, and the remaining can be allocated for the best effort. Now, does the customer wants to limit the traffic? So transmit rate is nothing but your PIR, right? So guaranteed rate is your CIR. CIR is a child rate, meaning you can have a minimum of 2 MB, but it can also burst up to 10 MB if there are no other queues getting utilized. Similarly, if you define PIR for a queue, it means if you define 2 MB and transmit rate as 2 MB, it means that queue cannot go beyond 2 MB. Clear? If you don't define a PIR, the PIR is going to be the port's bandwidth. So if you have defined the port bandwidth under the shaper rate as 10 Mbps, it's going to be, it will be able to burst up to 10 MB. And again, the traffic servicing within the queue, let's say, as we discussed earlier, right? So we have FCEF, which has 4 queues within FCEF, right? So now, if you assign bandwidth to FCEF as 2 Mbps and you assign FC5, which is media traffic, right? So now what's going to happen is the bandwidth will be shared between Q0 and Q1 of traffic class, of forwarding class EF. So that's how the traffic will be serviced. So let's discuss about schedulers and shapers. So as we know, the queue, there are forwarding classes which are NC, EF, AF, and best effort. And for each forwarding class, which is represented as traffic class over here, there are 4 queues each, represented by Q0, 1, 2, and 3. Now, every queue will be assigned to one WAN interface, one link, right? So in our case, we are assuming it to be VNI 0/0. And let's say if you have 2 sub-interfaces which are part of VNI 0/0, then the queues will be shared equally between VNI 0/0.1 and VNI 0/0.2. And individual shapers and schedulers will be assigned. So you might have done deployments based on this, like you can apply a policy map either on a physical link or on a sub-interface, right? So similar model can be done over here. Now, schedulers so when we say scheduler exists at port level and pipe level, it means it is available at a physical level and as well as a sub-interface level. And all ports have equal priority, meaning within each port, right? So let's say you have traffic on sub-interface 1 and you have sub-interface 2. Both will have equal priority for servicing the traffic. So unlike earlier that we discussed that the Q0 to Q1, that is only applicable per interface, meaning let's say I have traffic coming in on VNI 0/0.1 and 0/0.2. So when we say all pipes have equal priority, meaning if I have concurrent traffic coming here and coming here, both will be serviced equally. And within the port, right, so all the queues will be serviced from top to bottom on strict priority order, that is NC, EF, AF, and best effort. Now, best effort traffic can be subscribed for any oversubscribing traffic as well, like how we do it in our MPLS, that exceeding traffic can be put into best effort, can be done. Now, as we discussed, pipe is nothing but a VLAN interface. Now, let's discuss about dropper. So, what is a dropper? Dropper is nothing but it is nothing but a congestion detection method and as well as a tail drop mechanism, right? So, people who are familiar with QoS, they would be understanding the terminologies. Random early detection, WRED, right? So, this is a standard deployment that we do in our PE routers to ensure that we are dropping exceeding traffic either based on tail drop or we wait and then drop the packet. So based on that, the default mechanism that is applied on all the SD-WAN deployment is WRED, meaning all the traffic can be dropped, either tail dropped or be buffered to an extent defined on the queue length and then dropped. So there are 2 ways to do that as well. So here are the steps on configuring the scheduler, right? So first you schedule a drop profile, which is to ensure that again, it purely depends on the customer deployment, whether you want to define a drop profile or leave it to the queue buffer rate, which is basically till the traffic has enough bandwidth of CIR. Should it wait or should I start dropping the traffic as soon as my queue buffer length fills? Right. So then the second step is to assign that scheduler to a queue. Let's say you are assigning it to EF. The traffic class is assigned a bandwidth value for servicing this class for each of the queues within the scheduler in the assigned order. Right. So the third task would be to create a scheduler map. So basically, once you create a scheduler, which will say what is my guaranteed rate and what is my transmit rate, you assign that to the scheduler map. So scheduler map is a place where you assign the bandwidth to the traffic class. So as we discussed, NC0 is traffic, NC is traffic class 0, EF is traffic class 1, assured forwarding is traffic class 2, and best effort is traffic class 3. So based on that, it will be assigned. So this is a sample snapshot on how and where we define we create a drop profile, right? So the place where you see minimum and maximum is what we see as a queue length. So we are saying a queue length of minimum of 24 and a maximum of 128. So the next step is we define what is the CIR and PIR, right? So the guaranteed rate. So we can define the guaranteed rate in two ways. If you define in the interface what is your uplink and downlink bandwidth, in that case you can say the rate of the link. Let's say out of 10 MB you're saying 20% over here, meaning you have 2 MB of CIR and a 25% more. So basically it can go more than that 5% in the transmit rate, which is PIR. Right. So the next step is once you have created a scheduler, you're going to map that scheduler with a scheduler map. So as we discussed, so traffic class 0 is NC. So the created scheduler NC will be mapped to the network class. And so once you click OK, it will be applied. So till now, we have just defined what are the number of queues, what are the individual bandwidth for that queue. We haven't applied this to the port. We're going to do that in the next step. So the next step is under associate interface, we're going to select the link on which we're going to apply the scheduler map. So basically you can select either of your MPLS or internet link and then select the drop down and select your scheduler map. You can have different scheduler maps for different physical interfaces and transports. So once you have done this, and by default for SIFI deployment, we're not going to use anything for buffer size. So please ignore that. The reason being there are various calculations involved in defining a burst rate for a bandwidth. So there have been a lot of discussions. So as part of SIFI's standard deployment practices, we're not going to use burst size. So we are only going to say rate. So what is rate means? It is a shaping rate, meaning what is the maximum bandwidth this port is allowed to take, right? So first, either you drop the traffic in the ingress itself using policer, or you shape the traffic, which is drop the traffic while it is exiting your box. So my port bandwidth is 5 MB over here. So I'm saying that is the maximum bandwidth my box can take. So once you have defined this, the QoS is applied. And let's now look at how the packet flow looks like when the traffic comes in and it goes through various modules in SD-WAN. So towards my left, you see packets are inbound on port number VNI 0/2.10, which is my LAN interface, and it is getting classified based on the queues. Right? So there is a class AF31, TCP, and others. So you can see there are two segregations over here. One is based on DSCP bits. The bottom one, class type, class games, and class music, is based on application-based QoS mechanism. So next you assign a forwarding class to it, right? So now you have classified the traffic, it will be assigned to the forwarding class. So here it is assigned to the forwarding class 2 over here, right? And if you want to rewrite the traffic, it's going to be rewritten and assigned to the queue. Now once the traffic is in queue, it is going to be scheduled, right? So whatever CIR and PIR bandwidth that you have defined, it is going to take that bandwidth, shape the traffic, and give it to and then it's going to send it out of the interface. So that's the overall QoS packet life, right? So this is just to give you a high level. Let's just quickly skip back and see how do we define what all options do we have under application QoS, right? So application QoS is under the section class of service, app, costs, policies. Okay, so policy name is nothing but a general name. So in SD-WAN, a policy name is by default only one. Within a policy, you can define multiple rules. So based on that, you just click on the rule button, add a new rule name. You can match for the traffic going from which zone to which zone or which destination to which source address. Next, you're going to say is what kind of applications am I selecting over here. So here I've selected Skype and SIP traffic, and then I'm going to say which QoS profile should I apply that to. So as we have created a QoS profile called as voice, so all the traffic coming in with the match condition as Skype and SIP, it is going to be enforced with a QoS profile of voice. And again, as we saw, it's going to apply the same CIR, PIR scheduling policies while the traffic egresses out. So let's quickly jump and see how to configure that in a live environment. So let's see how QoS is defined in the SD-WAN director. Right? So here I have logged in into my template. Right? So let me just go back. Right? So just step a bit back. Let's say I've logged into the director. I'm going to the configuration, templates, device templates, and here you will see a list of templates. Right? So I'm going to go for the template which belongs to my site. I'm going to the site template name called as Ville-Parle. So basically it is deployed in our Ville-Parle office. So I've named it like that in a short note. And next I'm going into so there are various tabs over here. So that I have explained in a separate video on what are the different fields available over here. So under networking, class of service, first step, you create a QoS profile. So you go to class of service, click on QoS profile, click on the add button on the top right corner, define a queue name. So this is going to be your queue name. So as we discussed, we're going to give QoS1 as our Q1, right? And here we're going to define whether you want to rate limit the traffic when it enters the box or not. Let's say this is my voice traffic and I want to rate limit it to 2 MB. So people who have some confusion about why I'm writing 2000 and not 2024, we are talking about the bandwidth, right? So we're not talking about bits which we're going to transfer. So as a standard, we always follow into 1000. That's the bandwidth, right? So next we're going to select which traffic forwarding class it belongs to, right? So I'm going to select this traffic as forwarding class 4, which belongs to EF traffic class. Now, what is the loss priority for this queue? Since it's a video streaming traffic or a voice traffic, I'm going to give the loss priority as high. Otherwise, if it's a data traffic, I'm going to give a loss priority as low. So what is the difference? If there is a congestion, first drops will happen only in the high priority queue because it's not going to wait and buffer the traffic. It's going to drop the traffic when there is congestion. Low priority queue are not so latency sensitive. They can handle the latency or the delay. For those, they will have some buffer and they will buffer the traffic before giving it to the end host. For that, we need loss priority as low and high. So for video and voice, we usually suggest going with high priority. Step 2. So I'm just skipping the step right now for creating a rewrite rule, and I'm jumping into defining a QoS policy. Right? So as I discussed, always there is only a single policy. So you can name it as a default policy. So under policy, you have something called as a rule. Okay. So now you click on a rule, you add a rule name. So I'm calling it as QoS1 rule. Right. So next step is to define the match conditions. So I'm saying whatever traffic comes in from my LAN interface, and it is going to my destination network service provider 1, or if you don't define a source and a destination, what's going to happen is any traffic. So basically SD-WAN QoS is only applied for traffic between branch to branch via SD-WAN. So there is actually no need to define a source and a zone, destination zone, but as a standard best practices, just to know where you are applying and where it is applied, it's advised to go with a source and destination zone. Next step. go and select which applications you want to map as part of this rule. So as part of the new VD upgrade, we have some predefined filters called as high-risk applications, SaaS applications, and so forth. So I'm just going to select something filters as called as business traffic, and also I'm going to select a more specific traffic called as SAP. Let's say SAP. And also there are predefined application groups, so I'm just going to select SAP applications. And also I'm going to say traffic like SIP, real-time media are part of this application queue. So you have two options over here. Either you can select an application or you can select a URL category. So we have up to 83 different URL categories where you want to select. And always remember, when you're going to select any two boxes in this particular condition, it is an AND operation. Meaning, if you select business traffic, SAP app, SIP, and RTP, and on the next tab, which is URL category, if you select government, only if this condition matches, then this rule will be hit. Otherwise, it's not going to be hit. So it's always advised that you go ahead and define URL category rule separate from the application rule. Next step is to map this applications to which queue, right? So we just created a queue named as QOS1. Done. Click on OK. So the next step, you're going to define schedulers. So schedulers is a place, as we discussed, is to define the CIR and PIR for a queue. So I'm just going to name it as sched-QOS1. I'm going to define the bandwidth as 2 MB. Maximum it can go is 2 MB. So once you have done this, I would advise you to go ahead and create one more rule called as sched-QoS6 for accepting any traffic which is coming in for the best effort. So if your customer has just given you one QoS profile and remaining he has not defined, so it is up to you to go ahead and define one more QoS profile, QoS6. Map it for best effort traffic, map it with priority as low. That's it. You need not do anything apart from that. The next step is you just name it default and map it to QoS6. So now what's going to happen? Any traffic which is not matching this is going to match QoS6, and in schedulers we have defined transmit rate and guaranteed rate. So I have not defined anything, which means it can go up to the overall port bandwidth that I have defined. Next, I'm going to map the scheduler to the scheduler map. So that's the functionality of scheduler map. So I have mapped it to QoS1, which goes into traffic class 1, and QoS6, which is traffic class 3. Click OK. Go to associate interface. Add your WAN interfaces. So I'm selecting it as VNI 0/0, and the bandwidth of this port is 10 MB. I'm going to map the scheduler map. So basically what the scheduler map contains, it contains expedited forwarding and as well as best effort traffic. So just give the logging interval as 300. So what this signifies is it is going to keep logging the QoS related stats to the analytics. So click on OK, and we are done. So you just apply this template to the branch. If the deviation is in line to what you're doing, click OK, commit. Now we'll go back to the appliance and we will check whether this QoS policy is applied or not. Okay, the template commit failed. Okay. Device is out of sync. Okay, so when you get this error, so just go ahead, sync the appliance. Right, so now you see the template is committed. Let's log in into the CPE and check. The CAR is 2000 and the PIR is also 2000. For remaining queues, if you see, since we haven't defined anything, it can burst up to the port bandwidth. And over here, you can see your interesting traffic getting hit and it will be matched in this profile. Right, so and any drops you will see over here. Yeah, and that's it. And you can also see over here which interface it's supplied. What is the default burst size that got configured on its own, and what is the rate, which is basically the shaper rate of the port. So now, as you understand, 10 Mbps is my port bandwidth, which I've defined on VNA 0/0. Based on that, I have assigned 2 MB for my EF, and remaining traffic can be used by all of the queues. Thank you for watching.